The population of a town is given by the table year 1951, 1961, 1971, 1981, 1991, and the corresponding population in those years is 19.96 in the year 1951, 39.65 in the year 1961, 58.81 in the year 1971, 77.21 in the year 1981, 94.61 in the year 1991. Using Newton's forward and backward interpolation formula, calculate the increase in the population from the year 1955 to 1985. So for the given data, we have to calculate increase in the population from the year 1955 to 1985. So by using the appropriate Newton's forward and backward interpolation formula. So here you have to observe that 1955 is closer to the first value of x, that is 1951. So we have to use Newton's forward interpolation formula. 1985 is closer to the end point, that is the last value of x, that is 1991. 1985 is closer to 1991, so we have to use Newton's backward interpolation formula. So I am repeating again, 1955 is closer to 1951, so use Newton's forward formula. 1985 is closer to 1991, the end point or the last value of x, so use Newton's backward interpolation formula. Now construct finite difference table. Write down the x values: 1951, 1961, 1971, 1981, 1991, and now write down the corresponding y values. X is the year and y is population in the thousand. So y is 19.96, 39.65, 58.81, 77.21, 94.61. Now find the first forward differences. So taking the difference of the values in column y, so that is 39.65 minus 19.96 is 19.96, then 58.81 minus 39.65 is 19.16, 77.21 minus 58.81 is 18.4, 94.61 minus 77.21 is 17.4. Now second forward differences: 19.16 minus 19.96 is minus 0.53, then 18.4 minus 19.16 is minus 0.76, 17.4 minus 18.4 is minus 1. Then third differences: minus 0.76 minus of minus, that is plus 0.53, minus 0.23, then minus 1 minus of minus 0.76, that is minus 1 plus 0.76 is minus 0.24. Then fourth differences: minus 0.24 plus 0.23 is minus 0.01. So now after constructing the table, use Newton's case 1, use Newton's forward interpolation formula to find y of 1955. So y of 1955 means y stands for population. So x stands here, x denotes in the table, x denotes the year, y denotes the population. Y of 1955 means we are finding the population in the year 1955. So 1955 is closer to 1951, so So use Newton's forward interpolation formula. So we know the formula. So already we have discussed in the previous video. So formula is YR equals Y naught plus R into delta Y naught. Delta Y naught is first forward difference plus R of R minus 1 by 2 factorial into delta square Y naught plus R of R minus 1 into R minus 2 by 3 factorial delta cube Y naught plus R of R minus 1 of R minus 2 of R minus 3 by 4 factorial delta power 4 Y naught. So delta Y naught, delta square Y naught, delta cube Y naught, delta power 4 Y naught are all leading forward differences. So now we have to find the value of R. R is x minus x naught by h. So x is 1955 minus x naught, that is first value of x, 1951 by h. H is the difference between the values of x. So what is the common difference? Common difference between the values of x is 10. So R equals 1955 minus 1951 is 4 by 10, that is 0.4. So now we have to take the first values in each column. So the first values in each column are the leading forward differences, that is delta Y naught, delta square Y naught, delta cube Y naught and delta power 4 Y naught. So substitute all the values in the formula, that is in the Newton's forward interpolation formula. So y of 1955 equals 19.96 plus 0.4, 19.16 plus R into R minus 1, that is 0.4 into 0.4 minus 1 by 2 factorial. 2 factorial is 2, delta square Y naught minus 0.53 minus 0.53 plus R into R minus 1 into R minus 2 by 3 factorial, that is 0.4 into 0.4 minus 1 into 0.4 minus 2 by 3 factorial is 6 delta cube Y naught, that is minus 0.23 plus R into R minus 1 into R minus 2 into R minus 3, that is 0.4 into 0.4 minus 1 into 0.4 minus 2 into 0.4 minus 3 by 4 factorial is 24 delta power 4 Y naught minus 0.01 delta power 4 Y naught is minus 0.01. So y of 1955 is, so after simplifying using the calci, so 27.89. So while typing in the calci, you should be very careful. You have to verify 1 or 2 times. So you have to calculate the value accurately. So y of 1955 means population in the year 1955 is 27.89 thousands. So now case 2, to find y of 1985. Y of 1985 means we have to find the population in the year 1985. So 1985 is closer to the last value of x. So use Newton's backward interpolation formula. So we know the formula. Newton's backward interpolation formula is yr equals yn plus r into nebula yn plus r into r plus 1 by 2 factorial nebula square yn plus r into r plus 1 into r plus 2 by 3 factorial nebula cube yn plus r into r plus 1 into r plus 2 into r plus 3 by 4 factorial into nebula power 4 yn. So now in the formula we have to calculate r value also. R is x minus xn by h. X is 1985 minus xn is the last value of x. Last value of x is 1991 by h. Common difference between the values of x, that is 10. 1985 minus 1991 is minus 6. So minus 6 by 10 is minus 0.6. Now in the table we have to take last values. In each column we have to consider the last values. So last values in each column are called leading backward differences, that is nebula yn, nebula square yn, nebula cube yn, nebula power 4 yn. So in each column the last values are called leading backward differences. So y of 1985 is yn, first value is yn, first term is yn, that is last value of y 94.61 plus r into nebula yn minus 0.6 into nebula yn 17.4 plus r into r plus 1 minus 0.6 into minus 0.6 plus 1 by 2 factorial is 2. Nebula square yn is minus 1 plus r into r plus 1 into r plus 2, that is minus 0.6 into minus 0.6 plus 1 into minus 0.6 plus 2 by 3 factorial is 6. Nebula cube yn, nebula cube yn is minus 0.24. Nebula cube yn is minus 0.24 plus r into r plus 1 into r plus 2 into r plus 3 minus 0.6 into minus 0.6 plus 1 into minus 0.6 plus 2 minus 0.6 plus 3 by 4 factorial, that is 24 into nebula power 4 yn. Nebula power 4 yn is nebula power 4 yn is minus 0.01. Now simplifying using the calci, y of 1985 is 84.3. So the population in the year 1985 is 84.3. So now we have to find increase in the population from the year 1985 to 1955. So thus the increase in the population, from the year 1985 or 1955 to 1985. That is the increase in the population from the year 1955 to 1985 is, take the difference, that is 84.3 minus 27.89 is 56.41 in thousands. Let us solve the next problem. From the following table, find the number of students who have obtained A less than 45 marks and B between 40 and 45 marks. So here in the data, number of students and their marks were given. So first we have to find the students who have scored less than 45 marks. After that we have to find the number of students who have scored in between 40 and 45 marks. So in the given data, so marks of the students were given, marks scored by the students, it is given in terms of intervals. So this problem is very important. Marks and number of students were given, and marks is given in terms of intervals. So between 30 and 40, number of students scored is 31. Between 40 and 50, number of students scored 42. Between 50 and 60, number of students are 51. Between 60 and 70, number of students are 35. And between 70 and 80, number of students are 31. Now here take x as the marks scored by the students and y as number of students, but here marks is given in terms of intervals 30 to 40. So if we take the marks in terms of intervals, our purpose will won't serve. So instead of taking 30 to 40, take the number of the students who scored less than 40. Instead of taking 30 and 40, take the student who scored marks less than 40, and instead of taking 40 and 50, take the marks scored less than 50. And similarly, instead of taking 50 and 60 interval, take the marks scored less than 60. So now f of x or y represents the number of students less than x marks, that is take marks as x and number of students as y, that is f of x. So now students who scored in between 30 and 40, that is 31. So instead of taking the interval, take student who scored less than 40. So students who scored less than 40 marks is 31 students. Then students who scored in between 40 and 50, that is 42, but take the students who have scored less than 50 marks. So students who have scored less than 50 marks is, you have to consider the students who have scored in between 30 and 40 also. So the students who have scored less than 50 marks is 42 plus 31, that is 73. Now similarly, the students who have scored in between 50 and 60 is 51. So students who have scored less than 60 is 73 plus 51, that is 51 plus 42 plus 31, that is 124 students. Then students who have scored in between 60 and 70, that is 35. So students who have scored less than 70, so you have to add all the four values, 31 plus 42 plus 51 plus 35, that is 124 plus 35 is 159 students. Then students who have scored in between 70 and 80 is 31, but the students who have scored less than 80 is 31 plus 42 plus 51 plus 35 plus 31, or 151 plus 31, that is 190 students. Now we will find the number of students who have scored less than 45 marks. Now we have to construct the finite difference table or the forward difference table using this data. So in the table, take x and y. X represents the marks and y represents the number of students. So x is 40, 50, 60, 70, 80, and y the number of students. So y equals 31, then 73, 124, 159, and 190. Now third column is first forward differences. So in the third column, we have to find the first forward differences. That is denoted by delta y. So 73 minus 31, 42, 124 minus 73, 51, 159 minus 124, 35, 190 minus 159, 31. Then second forward differences denoted by delta square y. 51 minus 42, 9, 35 minus 51, minus 16, 31 minus 35, minus 4. Then third forward differences delta cube y. Minus 16 minus 9, minus 25, minus 4 minus of minus 16, that is minus 4 plus 16 is 12. Then fourth differences 12 minus of minus 25, that is 12 plus 25 is 37. So now we have to find the number of students who scored less than 45. So 40 less than 45 means it comes between 40 and 50. So 45 is closer to the first value of x, that is 40. 45 is closer to 40, so you have to use Newton's forward interpolation formula. So less than 45 means it comes in between 40 and 50, and 45 is very closer to 40, the first value of x. So you use Newton's forward interpolation formula. So we know the formula, yr equals y naught plus r into delta y naught plus r into r minus 1 by 2 factorial into delta square y naught plus r into r minus 1 into r minus 2 by 3 factorial delta cube y naught plus r into r minus 1 into r minus 2 into r minus 3 by 4 factorial delta power 4 y naught. Now we have to find r. R equals x minus x naught by h. So x is 45, because we are finding the students who have scored less than 45 marks. So x is 45 minus x naught, the first value of x, that is 40. X is 40, the first value of x, by h. H is the common difference between the values of x, 40, 50, 60, 70, 80. The difference is 10. So 45 minus 40 is 5. 5 by 10 is 0.5. Now since we are applying Newton's forward interpolation formula, so consider in each column, consider the first values. They are called as leading forward differences. So in each column we have to consider the first values. They are the leading forward differences denoted by delta y naught, delta square y naught, delta cube y naught and delta power 4 y naught. Now substitute all the values in the formula. So f of 45 equals y naught. Y naught is 31 plus r into delta y naught, that is 0.5 into 42 plus r into r minus 1, that is 0.5 into 0.5 minus 1 by 2 factorial is to delta square y naught is 9 plus 0. R into r minus 1 into r minus 2, 0.5 into 0.5 minus 1 into 0.5 minus 2 by 3 factorial is 9 delta cube y naught, that is minus 25 plus r into r minus 1 into r minus 2 into r minus 3, that is 0.5 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 by 4 factorial. 4 factorial is 24 into delta power 4 y naught, that is 37. So f of 45 equals f of 45 by using the calc. So while typing the equation you should be very careful, you have to verify 1 or 2 times. 47.86. So f of 45 is 47.86. so number of students you can't keep it in decimal number, so it is 47.86 is closer to 48, so it is approximately equal to 48. So thus the number of students obtaining less than 45 marks is 48. Now we have to find the number of students who have scored in between 40 and 45 marks. So now case B, we need to find f of 45 minus f of 40, that is number of students who have scored in between 40 and 45. So we know the number of students who have scored less than 40 and we know the number of students who have scored less than 45. So the number of students who have scored less than in between 40 and 45 is f of 45 minus f of 40. So f of 45 just now we have calculated, it is 48 minus number of students who have scored less than 40. From the table it is 31. So 48 minus 31 is 17. So thus the number of students scoring marks between 40 and 45 is 17. So the number of students scoring marks between 40 and 45 is 17 students. Now find the interpolating polynomial f of x satisfying the data f of 0 equals 0, f of 2 equals 4, f of 4 equals 56, f of 6 equals 204, f of 8 equals 496 and f of 10 equals 980, and hence find f of 3 and f of 4. So here we have to find interpolating polynomial for the given data. Interpolating polynomial means A polynomial means it is an algebraic equation which contains the terms of x. So you have to find the equation which contains only the terms of x. So now we have to construct the finite difference table or forward difference table. Write down x and the corresponding y values. When x is 0, f of 0 equals 0 means when x equals 0, y equals 0, f of 2 equals 4 means when x equals 2, y equals 4, f of 4 equals 56 means when x equals 4, y equals 56, f of 6 equals 204 means when x equals 6, y equals 204, f of 8 equals 496 means when x equals 8, y equals 496, f of 10 equals 980 means when x equals 10, y equals 980. So for the given data we have to find first we have to find interpolating polynomial. Using that interpolating polynomial we have to find the value of f of 3 and f of 5. So now to find the interpolating polynomial, use Newton's forward interpolation formula. So now to find the interpolating polynomial for the given data, we use Newton's forward interpolation formula. Now first forward differences denoted by delta y, the column is denoted by delta y, 4 minus 0 is 4, then 56 minus 4 is 52, then 204 minus 56, 148, 496 minus 204, 292, 980 minus 496, 484. Now second forward differences denoted by delta square y, 52 minus 4, 48, 148 minus 52, 96, 292 minus 148, 144, then 484 minus 292, 1 is 192. Then third forward differences denoted by delta cube y, 96 minus 48, 48, 144 minus 96, 48, 192 minus 144, 48. Then fourth forward differences denoted by delta power 4y, 48 minus 48 0, then 48 minus 48 0. So fourth forward differences are zeros. So now write Newton's forward interpolation formula up to third forward differences. That is, you have to write the formula up to delta cube y naught. No need to write delta power 4 y naught because it is 0, 0 multiplied by anything is 0. So now the formula is yr equals y naught plus r into delta y naught plus r into r minus 1 by 2 factorial into delta square y naught plus r into r minus 1 into r minus 2 by 3 factorial delta cube y naught plus delta power 4 y naught is 0, 0 multiplied by anything is 0, so no need to write. And now we have to find r. So in the formula we need r. So in Newton's forward interpolation formula, r is x minus x naught by h. So now for x, don't take 3 and 5. Don't take 3 and 5. You have to find the polynomial. So keep x as it is. In the formula, keep x as it is. So x minus x naught is first value of x, that is 0. So x minus 0 by h, common difference between the values of x, 2 minus 0, 4 minus 2, 6 minus 4, that is common difference is 2. So r equals x by 2. So now in the table we need leading forward differences, that is in each column you have to take the first values. So the leading forward differences are delta y naught, delta square y naught, delta cube y naught, delta power 4 y naught are the leading forward differences. Now substitute all the values in the formula. So now yr equals yr or it is nothing but f of x. Then y naught, first value of y 0 plus r is x by 2 into delta y naught. Delta y naught is 4 plus r into r minus 1, that is x by 2 into x by 2 minus 1. X by 2 minus 1 by 2 factorial is 2. Delta square y naught. Delta square y naught is 48 plus r into r minus 1 into r minus 2 by 3 factorial. X by 2 into x by 2 minus 1 into x by 2 minus 2 by 3 factorial is 6. Delta cube y naught, that is 48. Now simplify the equation to get equation in terms of x. So f of x equals x by 2 into 4. So 2 into 2 is 4. So then 48 by 2 is 24. 48 by 6 is 8. Then rewrite the equation as again to simplify further. So 2x plus x by 2 into, now take LCM, x minus 2 by 2 into 24 plus x by 2 into x minus 2 by 2. X by 2 minus 1 is x minus 2 by 2. X minus 2 minus 2 is x minus 4 by 2 into 8. Now simplifying further. So 2 into 2 4. 24 by 4 is 6. Now 2 into 2 into 2 8. 8 by 8 1. So f of x equals 2x plus x into x minus 2 into 6 plus x into x minus 2 into x minus 4. Now simplify the equation further. So after simplifying you will get x cube minus 2x. So this is the polynomial which contains only the terms of x. So it is a polynomial in x. So x cube minus 2x means highest degree is 3. So it is a cubic equation. So this is the interpolating polynomial for the given data. So after finding the interpolating form of a polynomial, we have to find f of 3 and f of 5. So in f of x, put x equals 3 and x equals 5. So f of 3 equals 3 cube minus 2 into 3. So 27 minus 6 is 21. Then f of 5. F of 5 is 5 cube minus 2 into 5. That is 5 cube is 125 minus 10 is 115. So this is the solution.